You can go ahead and start.
Okay, hi everyone. I'm Aslan Hadley. I work as an education specialist at IDB, and I'm going to tell you a little math study that we did, classrooms in Latin America. And briefly, I will tell you about reasons why we did the study and share a few of the results. So the reasons that this study is that we knew that Latin American students are falling behind other students internationally in both math and science. So even we control for GDP per capita, as you can see in these, Latin American students are compared very poorly to students from other countries. And even though we knew some of the associated factors with this poor learning, we didn't rely. When I talk about associated factors, it's school infrastructure, characteristics of the teacher, socioeconomic status of the students. We knew that those factors we could correlations with lack of learning, and even try to prove perhaps with lack of learning. But we didn't really know much about what was happening in classrooms and why there's learning levels. So those are the reasons we conducted this study. And we wanted really to answer questions: how are math, scientific thinking, and problem solving addressed in the classrooms? How does the teacher's knowledge of subject matter influence instruction? And what inquiry teaching practices play in the classroom, etc. And to pick methodology, then we looked at different types of qualitative research out there. We opted for one that many of you might know about because it's quite the TIMSS video study, which is quite old. It was done the first one was done in 1995, and then with just 3 countries, and then it was expanded in 1999. And we like the methodology. We like creators. And basically, what the TIMSS video study to film teachers in each country, and then try to compare cross-country the characteristics of the classes and each teacher once. So the study doesn't allow you to think about that specific teacher, but it does allow you to look at teachers from that country and look at cultural common of teaching in that country. So for example, what they found was that teachers in the United States, they start math lessons by giving a problem to the students and then showing the students how to solve that math problem. And then they have the students individually or in groups try to solve similar math problems. And this teaching practice is so common in the US. So any teacher who did not use that type of procedure to first help students how to solve a problem would be considered kind of almost weird. But the counterpart of those teachers in Japan, they do it completely differently. They give the problem, then they let the students try to invent ways of solving that problem, and then they bring together those the different proposals for solving the problem in a conversation with the students, and at the end of the class you reach the problem solving procedure and perhaps the formula. So it's a completely different way of teaching, and that's what this methodology can help you find, like cultural traits like that. We opted for looking at 2 of the bottom performers in the regional SARCE, which is Dominican Republic and Paraguay, and then 1 who was the second best performer, which was the state of Nuevo León. So those were the countries we looked at. We filmed 84% of the SARCE sample in these countries, both classrooms. We filmed over 2,000 math problems and hundreds of science segments. And the coding took an entire year with 11 content experts in math and science and 11 pedagogical experts. And the study has around 150 indicators. So here I will only be able to share like a handful with you. And then turning to the findings. And so what we found was that the teaching was largely relying on presentation of repetition of math procedures, usually combined with drill, practice, and memorization. So for example, in this slide, you see that students in Paraguay, for example, they spend 39% of their lesson time practicing routine procedures in the math lessons. And then the other 60% or so of the time they spent applying concepts that they had learned, and actually tasks that involved some critical thinking was only 2%. And in contrast, if you compare that to what they had found in the TIMSS video study in 8th grade, then Japanese students, for example, spent 44% of their time inventing new solutions. Also, if we look at widely considered very math literature, which is to look at alternative solutions to math problems, that it's not only one solving a math problem, but you can have math problems in different. And then we found in the Latin America, the 3 countries that we looked at, there it was basically kids learned one procedure math problem, and they never in the class alternative solutions. For example, the 8th grade students in Japan, and 42% lessons they had they presented alternative solutions to math problems.
Emma, Emma,
yes.
Some people are having trouble. A little bit closer to your webcam or to your mic.
Okay, is that better? Do you hear? Okay. I'm terribly sorry about the issues here in my house and the connection from here that caused the problems. Okay, I'll try to speak loudly and and interrupt again and tell me if I need to speak even louder. I'll do. Okay, sounds good. So then just looking at science, for example, in the TIMSS video study, then they used like a wide spectrum of indicators to assess the level of inquiry used in the lessons. And a particularly interesting indicator allowed us to code the lesson according to how scientific content was developed. If it was by stimulating students to make connections among ideas, experiences, patterns, and explanations, or by acquiring facts, definitions, and algorithms. And as you can see, then in only Nuevo León did the kids spend a little bit more of their science lessons actually making connections. And when it comes to actually the proportion of science instruction spent on seat work compared to practical work, then that's also very interesting, because there we found, if you see like the pens, which is the first column, that's where kids spend time doing only seat work. And as you can see, that's most of the time was seat work. And when it comes to practical works, which is the test tubes there, then most of the area is gray, which that's the time that was actually whole class practical work. So basically it's the teacher doing the experiments. The kids don't do the experiments themselves. And what's interesting is that the little time, like the red little dots there, the red parts on the test tubes, which is when they actually did independent work in group or individually. And then unfortunately they weren't there formulating new hypotheses, but the work was limited to verifying knowledge. So for example, rather than asking students to formulate predictions about the density and mass of different materials and then design experiments to test their predictions, the teacher might tell students that copper is more dense than aluminium, and then the students get to confirm that. So the practical work was very kind of restrictive. And then when it comes to the math content, then we also looked at a whole series of indicators to assess students' opportunities to actually learn math content. And one that I found interesting was whether you actually spend the bulk of your lesson time reviewing previous content or whether you're actually learning new math content. And what we found was that most of the lessons, they were actually just spending reviewing previous content, and very little time, as you can see in this graph, was spent looking at new content. And then when it comes to the complexity of math problems, the way in Tim's study works, how complexity was defined is how many problems that a math problem has. So if you have many sub-problems and the math problem involves lots of decision-making processes, then it's defined as a complex problem. And then a math problem that doesn't have any decision-making or sub-problems, that's low complexity. And as you can see here, almost all the problems were lacked in complexity. The same thing in science, where it was also very low complexity. And then finally, I wanted to share this graph that I find very interesting, because when the sources of content for a lesson, it actually tells you a lot about the lesson. So for example, if you use textbooks in a lesson, that can help the teacher actually structure the lesson. And if you have a lesson where kids get to look for content from various sources, a library or a survey that they do with parents or other teachers or students, or if they get content from searching on internet, perhaps if they have access to internet, then that might show that you actually have some inquiry in the lesson. Whereas if the teacher is the only source of content, it shows you also something about the teaching style. And what we found that in the bulk of lessons in 3 countries, then the bulk of the lesson time was the teacher was the main source of content. So only in Nuevo León was it a little bit more use of, for example, textbooks. And this finding that the teacher is the main source of content is also very consistent with the surveys that we applied to all teachers, where they described their own role, and they tended to describe themselves as the role of the teacher. They tended to describe as transmitter of content. They didn't see themselves as facilitators of learning, but as transmitters of content. And the role of the teacher as a transmitter of content becomes very problematic, given that often the content they transmitted had errors in them. I don't have a slide on this, but when we looked at actually what was being taught, we found loads of errors. For example, in Paraguay, then 59% of science lessons, the teacher committed at least one, often multiple errors, and they were often quite grave errors, both in contents or in procedures being taught. So, for example, one teacher also in Paraguay, I think, was insisting that wood is much density of metal, and there were lots of when it came to of the human, so especially where we found lots of stereotypes being transmitted. And this is, of course, very problematic when the main source of content is the teacher, and then the teacher tells you things, procedures that are. And then just as a conclude, this study is qualitative. It's a large-scale qualitative study, which from the characteristics teachers and teacher attributes to actually what's happening. We find a lack of interactive and inquiry-based approaches. We find that in science, kids spend the bulk of time memorizing science, memorizing facts. They learn math procedures, they memorize formulas. They don't actually learn critical thinking skills. They do experiments. It's mainly to verify facts, not to actually test their own. So, and from there, let's go to questions. Wonderful. It's the teachers are the teachers from the CERSE test. So it's a huge variety, and basically they reflect the proportions in that country. It's the CERSE test is a representative sample of teachers in each country. So it's a large scale standardized test. So there's teachers from private schools, from public schools, with lots of experience, newer teachers. They're equally, they reflect, and we verified this, that they reflect the proportions of in the country. So since we went with the same sample, then basically it's the characteristics of the teachers are characteristic of the teachers in the country. It's mainly from public schools, but also an equal proportion of private school teachers as there is private school teachers in that country. Well, that's the million-dollar question, how to go from there. This study, what we tried to do was actually explain what's happening in the classroom so that it would help inform us when it comes to working with our counterparts in developing interventions in classrooms. At the IDB, we're also working very heavily with governments to develop new ways of teaching and testing those in experimental pilots where we have a group of students that receive like the traditional way of teaching, and then groups of students that receive alternative or new ways of teaching. And we've had quite good results. So on other occasion, I'd be happy to share some of the results from those experimental pilots with ideas on how you can actually, in next work, teachers, huge content gaps, pedagogical gaps, how can you help those teachers shift to more inquiry teaching practice? It's exact same thing. And I think that the national test, not the regional standardized test, but the national test, they're very focused on things that get slightly higher scores by rote memorization, and that's why the teaching is focused on rote memorization. Whereas the regional standardized test, that no longer works, because it actually tests a little bit more inquiry-based skills, etc. And just like the PISA test or the TIMSS test, and that's why Latin American students then score so poorly on these international standardized tests. Mm-hmm. Mm-hmm.
So please type in any questions that you have in the chat box, and then I'll convey them to Emma. So it looks like people are typing in. Okay, Shireen from Save the Children has a question or comment. She says, "Thanks, Emma. Great presentation and love the graphics on the slides. Could you talk a bit about the teachers in this study? How long they've been teaching for, what their background is, whether they received professional development for science and/or math from their schools?" Okay, Shireen from Save the Children has a question or comment. She says, "Thanks, Emma. Great presentation and love the graphics on the slides. Could you talk a bit about the teachers in this study? How long they've been teaching for, what their background is, whether they received professional development for science and/or math from their schools?" Okay, thank you. Matt, who's connecting from India with Easy Vidya, asks, "It sounds very similar to the scenario here in India, knowledge, not thinking. So how do we help low-skill teachers change their focus?" Okay, thanks, Emma. We're getting a couple of more comments or questions being typed into the chat box. Sorry, there's always a little bit of a delay when people are typing in, and then I'm able to see it. Okay, so Matt has a follow-up, and he says, "There is a linked problem in India in that the assessments are very much focused on marks that you can get through mugging or rote memorization. How does this compare to the assessments in your study's countries?"